Sure. I'm Jesse. I work for OCD Automation. We do industrial automation systems integration, which doesn't tell you a whole lot about it. But basically, we are consultants, so we work for other companies. If you have a factory and you have a bunch of equipment, you'd like that equipment to do something specific, we will design the electronics and make the electronics and program the electronics to do that sort of thing. I went to University of Portland for mechanical and almost electrical engineering. I would recommend picking one at a time. And then wound up with CH2M Hill, which no longer exists, but was an engineering firm that I worked with for a while. And then wound up at OCD Automation through various means that we can talk about later if you guys are interested.
My name is Stacy Ade. I also work at OCD Automation. Again, like he's saying, system is integration. The best way I always think of to describe it is if anybody has ever seen how it's made, how it goes through all the factory, it goes from this machine to this machine to this one. We work on the design, the programming of that process to get it to work like it's showing on there. I went military actually first. I used the education benefits from the military to go to the Perry Technical Institute in Yakima for their 2-year instrumentation program, and then I got hired on at OCD right out of that.
My name's Rylli. I went to Perry Tech right out of school. I work for OCD Automation like these two. My day-to-day varies on what I'm doing. I could be called to a new site, troubleshooting stuff, or I could be designing a system, wiring a panel, all sorts of stuff. So.
My name is Ryan. I'm an Associate Design Engineer for Clark Public Utilities. I went to Clark College, got an Associate Science Transfer degree, went to WC Vancouver, got a Bachelor's in Electrical Engineering. I'm in charge of all electrical construction north of WC Vancouver, designing, maintenance, etc.
My name's Paveglio. I'm a geotechnical engineer. It's basically a specialized form of civil engineering that deals with soil, so geosoil. I work for a company called Columbia West. We primarily do consulting engineering. Went to WSU, have a degree in civil engineering, then a master's from WSU with an emphasis in geotech.
I'm Kat Clark. I'm a mechanical engineer at Bonneville Power Administration. We transmit power from the dams, which is managed by the Army Corps of Engineers, to our customers, which are local utilities like Clark PUD. I've worked in several different groups at the company. Currently, I'm a test engineer in the mechanical lab, so I break and test mechanical components of the transmission lines or the transmission system. And I went to the University of Washington to get my mechanical engineering degree, and went through the student program there to get a job at BPA after I graduated.
I'm going to do the first couple of questions, and then I'm going to have a couple of you guys ask questions, if you're okay with that. Okay,
sure.
Great. Explanation. Please provide an explanation of the work your organization does and share a specific type of engineering. Oh, you already did that. Is this the second time you guys sat through this? Okay.
Well, the first
time we went sort of sideways, so
yeah.
We can give some
we
examples.
We didn't do any
of
of this last time.
I've got examples.
Yeah, it's because it was Reinhard.
I mean, if you want, who's actually interested in what they do, like day to day?
Like us or them?
Their day to day is
school and more school. It's the same thing.
Yeah.
We'll start with what's your background? Why'd you choose this path? And we'll start on this end this time.
So my background is, I went through high school, and I went into UW thinking I'd be an engineer of some sort. I liked math and physics, and I thought they had pretty good job prospects as well. That was a plus. But I chose mechanical engineering over structural engineering because I like things that moved. I didn't want things that stood still, so I like dynamics a lot. And I found that I like renewable energy, and mechanical engineering was like one of the more diverse majors. It was pretty flexible. You could go into heat transfer, you could go into mechatronics and robotics, you could go into renewable energy. So there's like a lot of different paths you could take in mechanical engineering. And I found out like at one of the career fairs that I went to, like Bonneville Power had a student program. And they still do that where they have students during the summer from like colleges in the Northwest, and you earn money while you're at the internship, and you're more likely to get a job after you graduate when you go through their program. So I was lucky enough to have a job available for me when I graduated. I worked for a few years in facilities engineering, so I designed HVAC systems and backup generators and all that. I did a detail, which is kind of like a 4-month internship in a different group as an energy efficiency engineer. So I worked with local utilities to help save power usage in their buildings. And now I work as a test engineer in the labs. We have electrical lab, a chemical lab, a structural lab. So yeah, we just get to test things all day, but we have to write reports about it. That's the thing. It's like, okay, we have to do some writing, but yeah, it's been pretty fun so far.
I didn't know what I wanted to do. Parents and teachers say engineers make pretty good money, so I was like, I'll try that in college. So I went, tried it, and when you start out in engineering, basically everybody kind of starts in the same group, and then as you take classes, you kind of specialize. And so I just went towards geotech because I enjoy it more than the other ones, and so I mean, just got into the field, and here I am, 20 years later, still doing it. So
Yeah, sorry.
Go ahead.
I was always interested in math, good at math and physics, and I needed a job. I had a young child and another one on the way, and I needed to finish college and start making money. So engineering was the path that the counselor said I should go on.
So I went to high school, had no idea what I wanted to do. I'd say my strongest, the core subjects that you learn, math was it. I enjoyed technology. I knew that technology was the future. It'll always be a great industry to get into because things will always be improving. Everybody wants to improve their efficiency when it comes to making stuff. I was kind of burnt out at the end of my high school era, so I knew that max that I would be able to do is 4 years. And I'm from the Longview area. It's kind of a joke that everybody in that area knows about Perry Tech in Yakima, Washington. So I did their instrumentation and industrial automation program. It's basically 2 years. You get in, they teach you just what you need to know, no extra classes, nothing like that. Pretty hands-on, so it's not the typical, you still sit behind a desk, but you're in a lab and you get to actually wire stuff and build stuff and see physically what you learn about, and all the formulas that you learn, you get to actually apply it to a physical thing. So I got in, got out, and I've been working at OCD now for 3 years, and that's my first job I've ever had, and so that's what I did.
So I'm from Rainier, Oregon. It's right next to where Rylli grew up. We're basically from the same place. But like her, math has always been my best subject. The thing is, I've always tried to do what my dad did. My dad was a millwright at the paper mill over there. So initially out of high school, I tried to get on at the paper mill to try to get through the journeyman program like my dad did, because I didn't want to go to school and get into massive debt. That was my thing. I didn't want to take out loans in order to go to school. Didn't have any luck getting on at the mill. Ended up going military. Did 6 years in the military, and I used the education benefits from that to go up to Perry. Now when I was going up there, my dad had always been telling me, go to Perry, go for instrumentation. Go for instrumentation. No, don't do journeyman millwright like he was, go for instrumentation. So I got into the class not really knowing much about what instrumentation was, but it did have a good amount of math in it, and I did find myself enjoying the hands-on and problem solving, and I love the job, to be honest.
I have been fortunate. There's never really been a whole lot of doubt that engineering was going to be my thing. I attempted to build a hovercraft in high school. It was not successful. But after high school, I went to the University of Portland. Like I said, I attempted to do mechanical and electrical engineering at the same time. Don't do that. But I finished the mechanical degree, and then while I was in college in the summers, I was working for my dad, who owned a sawmill. And part of the wood products industry is that nobody has any money, and so if you've got like a 19-year-old that kind of knows computers, why not have him do your programming? So I sort of got into the automation stuff over the summer. I was fortunate to do that. You can call it an internship. It's kind of not an internship when you're working for your dad, because sometimes you have to shovel. But after college, I went to CH2M Hill, which was sort of an engineering company. And I was in the industrial automation group for that, so I got some exposure to the engineering side of things, the design and drawing production and so on. And then moved over to OCD Automation, where I'm doing a lot of the practical side of things as well, the field work and the interpretation and all that fun stuff.
All right. Just a random question, show of hands. How many of you guys have to do lean stuff on a regular basis? Like lean or Six Sigma, that sort of?
We interact with it a lot. So being consultants, we're not generally we're not responsible for the rules themselves, but a lot of what we do ends up going into those sorts of programs for, you know, the quality and so on. Somebody will need to do something for their Lean or Six Sigma program, and they'll come to us and say, we need to verify that this chemical has a concentration of X, Y, Z. We need to do it automatically. We need to divert if it's not. So we end up working on that sort of stuff, maybe not as the principal person, but definitely something that comes into our.
Nobody else.
Don't even know what you're talking about.
I worked at a water quality lab before I was a teacher. We were a lean lab, so every day we'd have to cut processes or figure out what processes we could make faster. So that.
Nope.
Nope.
I mean, people just beat us up about money. It's the same thing.
Yeah, like you guys are wasting too much time.
Yeah.
Yeah.
Better.
That's lean.
Yeah.
When you're charging the client $175 an hour for your presence, you're aware of the time that you're spending.
We'll start back on this side again, and we'll do. So, what do entry-level positions look like in your organization?
Good question. Generally, entry level is going to be a lot of field work. So, going out to a site that's having a problem. Our flow meter doesn't measure our flow, which is not great for a thing that's called a flow meter. And you might be using electrical tools to try and diagnose, you know, what's happening there. You might be using your computer and your programming tools to open up the interface for the instrument or the interface for the computer that it's talking to. You might end up doing some wiring in our panel shop, because we build the brain boxes, I guess you could call them, that have all the signals that come in and go out and have the controller in there, and somebody has to put that together, and that's you. But really a lot of field work, a lot of tagging along with more experienced people, and a lot of just doing the job and figuring out how it works.
What education is required for entry level?
Some. It's nice to, I should say this is for our type of thing. If you're doing real engineering, it's much more specific, and I'm sure people will get into that in a minute. But for us, we want you to have some knowledge of electricity. So I put my meter here, and I expect to see 120 volts. What is that? What does that mean? Some slight mechanical knowledge. So the idea that a motor is connected to a pump with a gearbox and what all of those things kind of do. But the big thing is communication and computers. So being able to write a professional email that can communicates a specific point in as few words as possible and as politely and businessly as possible, and the ability to use Word and Excel, and maybe command prompt if you're really fancy, and maybe being able to install software and you know, computers, right?
Going through Perry Tech, your entry level is really going to depend on what company actually picks you up. Like, Jessica kind of gave the rundown of what entry is for like OCD, but for example, I had other classmates, they went to paper mills up in the Seattle area. So they're out there, they're calibrating transmitters, they're checking pipes, checking valves. It's a bunch of calibration stuff from my understanding from what he sent me. We got
Calibration being, if you have a sensor and it's telling you something,
is it actually what it's telling you?
You have to get another sensor and measure the same thing and see if they say the same thing. And if they don't, then you need to go get another sensor
And see which one
and
is
measure
wrong.
it a third time and see if you can determine which one's wrong. And if this one's also saying something different, who knows at that point?
Our company doesn't do a whole lot of that, but that is a big part of the instrumentation game.
And it's a big part of instrumentation. Like there's kind of almost 3 different avenues that people typically go to out of Perry. The third one's not quite as much because there's the programming side, which not as many people get into because normally they want people that have been in the industry for a while, got a lot more experience. And then you've got the contracting companies, which can do any number of things like OCD, or you've got the actual instrumentation tech at a paper mill at Genentech, for example, is another one that will hire them out. And again, it's a lot of the calibrations. You're checking to see if this instrument is, which is saying it's got 100 GPM of flow, gallons per minute of flow. Does it actually have 100 gallons per minute of flow? Well, let's put this other one here to measure flow with this. Do they say the same thing? If they say the same thing, likely it is.
I think there's a question there.
How do you hold 3 sensors when you only have 2 hands?
And fingers.
Hold 2 in one hand.
Get a table.
Pretty simple.
That's the job. You got to figure it out.
Yep.
You got to come up with a way to do it. And oftentimes,
Yes,
it's a pipe, and there's no way to open the pipe because it's full of 150 degree sodium hydroxide.
Yeah.
So like, some of the design is going to be designing in a way to test it, or maybe you have a tank downstream and you can fill it for a certain amount of time and integrate. I saw somebody with a calculus book here. The book scares me, but the integration doesn't. So maybe you need to come up with a different method for calibrating it, or maybe you need to have, that's the job.
The other
That's
thing
what
is,
takes
well,
some time.
with those also, if you go to a specific company and you're hired on at a company as an instrument tech, they normally have books and books of procedure. Okay, for this calibration, you grab this stuff, you take it on a cart over there if you need a cart. Do this, this, this. Okay, you've got the calibration done. You head out to your next job.
That's the interesting thing about Stacy and I going to Perry Tech versus like getting a degree at a college. Is a 2-year program, so we didn't graduate with a degree, we got a certificate. The reason why that certificate holds any value is because Perry Tech has big board meetings with industrial people, leads, bosses, and they say, hey, we want your students to come out knowing X, Y, Z. So that is what gives you the value because they trust the teachings at Perry Tech. So like I go from place to place, I'm a contractor, but other places, my boyfriend went through the same program and he works at a semiconductor plant. He goes there every day. He works, Monday through Thursday. He works his schedule. And for me, I could go in on a Saturday if there's an emergency. I could work 5 hours on Monday because I worked 12 hours last Friday. It's totally depends on what path you want to take. And with instrumentation, at least, your day-to-day can look drastically different, which is also a reason why I chose that program from Perry Tech, because if I ever get bored of programming, which I don't think I will, I can choose to sit at the same machine every single day for the rest of my life with my handwritten procedure, and I won't have to think at all. There's many different places you can go to.
So the question was about students. What was the question?
What's entry level look like?
Entry level. Okay, so entry level. We've got a handful of like student interns. We've got 10 engineers. 3 of them are like silver tsunami guys that are not doing anything. So the student interns, they're gonna do the stuff that like we don't have time to do. We don't want to do. Like for example, I'm doing a reconductor out in Battleground Lake right now. It's 37 poles, probably about 3.5 miles of cable. So I sent our intern out there, I gave him a hammer, I said, just hit the pole. Does it ring or does it thud? If it thuds, it's rotten and we have to replace it. If it rings, it can probably go another 10 years. So I just sent him up there and had him hit every pole. Write down the number of the one that needs to get changed out, bring it back to me. Like if you're a Bitcoin miner or a marijuana grower, and you're burning up your service wire, we'll put a PQ light meter on your service that'll take a snapshot of your usage like every 15 minutes for a whole month. And then we'll get this huge bundle of data, and I'll give it to the kid, and I'll say, put it in a spreadsheet, highlight the highs, highlight the lows, and then give it to me so I don't have to sort through all this stuff. So that's what you're going to be doing. Just the stuff.
It sounds silly, but there's a lot of stuff that
takes like two, 3 days, you know?
Yeah, and somebody has to go through the details, and that's a really good way to learn the background is by going through the details.
Have you guys seen Karate Kid? It's kind of like that, you know. We're really teaching you by giving you these like silly tasks, but but yeah, you go out in the field, you're hands-on, and you actually get to see the equipment. So there's always something to be learned by.
Is that it? Oh,
No.
so mine's a little different. So I mean, in our field, you have to have a degree in civil engineering. We prefer a master's in geotech, and basically what you do when you first start out is we do design that are the guys in the office, and so when we design, we put our stamp on there, and then we have to go out there and make sure that our design is being constructed correctly. So when you're entry level, you're that person that goes out in the field and probes foundations or watches drilled shafts goes in or driven piles or looks at slope. So basically what you're doing is you're going out in the field the first 2-3 years to figure out what really happens when you're designing in the office, so you know how things react and not just how they say they do in a book.
Yeah, that's kind of what it's like in my office as well. Like when I was in facilities engineering, like when I was a student, they had me take a drawing of a pipeline from the 1940s, and was like, okay, what's the elevation change and how long is this pipe, and how much flow rate or how much head or pressure is that water losing by the time it reaches the bottom, the top. But so yeah, we have our interns do calculations using Excel. There's a lot of Excel work, reviewing drawings and standards and specifications, and maybe help write those as well. And yeah, a lot of things that we don't have time to do. Like if we want someone to check our work, we'll have the interns or the newly hired employees do that.
What are the opportunities for progression within your organization, and what are associated pay ranges? So what would you start at and what would you top out at? And is there room for advancement, or you just start and that's what you do the rest of your life?
So BPA is a federal company. We're under the Department of Energy, so we have the GS pay scale. The students get paid GS level 4. Probably doesn't really mean much to you, but that's around $40,000 per year. If you graduate as an undergrad, you might start at GS 7, which is maybe around $70,000 per year or so. If you have your master's, then you might start at GS 9, which is around maybe $84,000. And once you start, if you start in the student program, then you're kind of on an accelerated progression. So within 4 years or so, you'll go from GS 9 to GS 12, and then from GS 12, which is a 6-figure pay scale or pay range, then you can apply for a GS 13. So it's pretty set, and at BPA, I think maybe 5 years ago or so, all the engineers got a pay raise, and compared to other companies like Army Corps, for some reason we got that pay raise, and that was pretty sweet. But yeah, I liked it because of the stability and, yeah, you do work quite a bit. You do work hard for your money, but it's pretty rewarding.
If you guys are curious to go from annual salary to hourly wage, you divide by 2,000, so $40,000 a year is about $20 an hour. 100,000 a year is about $50 an hour. That might be more approachable for having worked hourly jobs.
Yeah, we're similar starting to what they are, probably 75 to 85, depending on masters, or I mean, some people have PhDs. If you want, I mean, you have to have the want to, and you can keep going up, and typically you'll max out around 15 years in, and you can make several $100,000 a year, and then on private industry, so you can do bonuses and stuff like that. So depending on how the company does and how the owners want to share money, then you can also get bonuses on top of that. But again, not everybody gets there, and if you don't put the effort in there, you're not going to get there. So you can also stick it where, something in the middle and stay there. And some people like that. I mean, if you want to make more money, you're going to have more responsibility and more stress. So it's going to come with the money. So you can get to the top level if you want, but you can also stay. We have people that don't want to have the stress of sometimes managing multi-million-dollar project kind of stuff. So.
Yeah, so like they said, about $20 an hour is the student rate for the student interns. In my career, I started out just doing regular houses, like residential services, 200 amps a piece, new build houses. Then I kind of worked my way up, single phase stuff. There's a wide variety of jobs that you can do. Right now I'm doing I'm designing the Costco in Richfield. I do pretty much all electrical construction in North County. So that's everything from the houses to the Costco's. Agency projects where we're putting power lines underground. We've got Pioneer Street coming up next spring. We did 11th, pay rail, like he kind of said, pay range depends on how much work you want to do, where you're comfortable at. You get to the spot where you are comfortable financially, you stop growing and just stay right there. But you can probably max out at a couple $100,000 a year.
For my field of work, especially being right out of school, it totally depends on where you go. For example, the boyfriend, he works at Analog Devices in ADI in Camas. He started out making above average. I would say average coming out between 40, 60. He was in the 70s. And it's one of those things where it's like, okay, you're a Tech 4, you're Tech 5, or you're Tech 3, and then within that tech level, Tech 5 is going to make this range of money, Tech 3 is going to make this range of money. Typically that goes up by, you get a review every year, and then you can be promoted, or you work there long enough and you get moved up. With OCD, when I started, it was the boss. It was Jesse as the next senior person, me as the newest person, and then a guy named Sean who had been there, I think, for a year or two when I started. A little bit different. It was more so, hey, I've been here for 6 months. Are you going to keep me? And he kept me, and he gave me a cost of living raise. And every year, I've gotten pretty decent raises. Totally depends on where you go. I'm salary. You can get an hourly job. You can get an hourly job with overtime. You can get an hourly job with no overtime. My boyfriend gets a lot of bonuses throughout the year because he works for a big company type of thing. Totally depends on where you want to go.
I'd rather say, because also, again, I was in Perry Tech, it really depends for starting pay on where you go. And I've seen people, from my class, that was another thing about the instrumentation program in OCD, in Perry Tech, is the instructors pride themselves on the fact that none of their students show up for graduation because they're already all out working in industry.
We were all hungover, but
because they're already all out working in industry. And I think the lowest that one of my classmates accepted was 28, but that was because he was wanting to go to one of the eastern states And so that was his way of getting his foot in the door over there with the intention of finding somewhere else that pays a lot more once he gets over there. And I think the highest, there was 28 an hour, I should say, not 28,000, like 28 an hour. And I think the lowest, or the highest was 45 an hour. I think one of the guys got up to 45 an hour. So but again, it really depends on what industry you get into, what you're going to do. If I remember correctly, oil tends to pay higher. So you can get into
because it sucks more.
That's the other thing as well with that. If you want to go Alaska, that is one of the ways to get in there, contracting for oil companies up in Alaska.
To speak a little more to the progression, usually at least in the two engineering companies that I've worked for, there's two ways you can go. You can become a technical manager or project manager, or you can become a technologist who does the more complicated problems, the more complicated design stuff. So either you become more responsible for people and projects, or you become more responsible for technical aspects of things. Both of those have plenty of room to grow. You can make as much as you're willing to sacrifice for, basically. You will absolutely be comfortable with a job like that. Travel actually can be really lucrative because you're not paying for your food, and you're not paying for your car, and you're not paying for any of this other stuff. So especially while you're young, traveling can be a good way to earn some extra money, and also learn a whole lot of interesting and sometimes crazy things. But yeah, as far as progression, there's all sorts of places to go.
My coworkers like to say they're going on vacation anytime they go on a work trip.
I went to St. Martin one time because they needed somebody to push like 3 buttons. So I was there for a week scuba diving. It was tough.
Unacceptable.
That's totally acceptable. What are you saying?
But then the hotel blew away in a hurricane, so
Dang it. Oh, let's start now.
yeah.
You pressed the wrong button.
If you guys have any questions, feel free to ask too. This is not for me. I have a career.
Are these guys freshmen?
A bunch of them. Raise your hand if you're a freshman. Raise your hand if you're a sophomore. Junior? Senior?
Yeah, that's
Raise your hand if you had calculus.
Ooh, good idea.
Yeah.
That's weird.
I took AP
Raise your hand if
calculus,
you remember how to do it.
then I got to college,
That's the hard part, right?
and they were like, that doesn't count.
First did about 3 months after I was done.
Quit touching your devil.
I can tell stories if you want. Or,
Please.
Yeah,
I mean,
Or,
we have questions here to ask, and
whatever you
we
like.
probably shouldn't, but like all your companies use interns, right?
Yeah.
Generally, college interns.
Yep.
Are they paid?
Yep.
All of them are paid.
Here, I brought a bunch of, I printed out a bunch of like stuff to hand out. Here, look at these. These are like job descriptions for interns.
Yeah, that's what we hire a lot of people is college interns, and if you're good, we wait till you get out of school and we hire you. But if you're not good, we don't go
I got my first job off an internship. They paid me for the last half of my senior year, and then they hired me after. So that's a great opportunity.
The schooling only gets you so far in engineering and technical fields. It teaches you how to think, and it teaches you the background basics, but it's really the internship or the first job or the extracurricular stuff that really gets you to where you need to be to do something useful.
So you're saying on-the-job training is more important than the...
Oh, absolutely. I still get on-the-job training because nothing we do is ever the same twice.
I think the most valuable skill is common sense, honestly. Like just being able to understand if that makes sense or not in the application of anything. So again, you have the schooling background that teaches a little bit and more or less weeds people out, then the on-the-job training and then applying that and to common sense. Is this what you get with a lot of engineers that come right out of school is you tell them to do some calculation, they do it, and you're like, there's no way, right? you can just look at it and know, because they don't have that common sense. So they have to learn that and then apply that when you're dealing with other people and in the field.
Yeah, everything always works on paper. And once it gets out in the field, that's when it goes south, right? So you got to know what's going to work in the field and what's not going to work in the field. And you get that by doing the job for years
and figuring out why it's not working.
You can design the problems out of your jobs before they happen.
Oh yeah, I learned the most from things that went wrong.
Yeah, right.
For sure.
As the instructors at Perry's would say, the most valuable thing that they can teach us is how to learn.
Yeah, I had to learn what the dielectric constant of water was yesterday. I didn't even know what a dielectric constant was until yesterday, because it was in the menu for the instrument, and it's like, somebody should probably set this. And the instrument worked better after I set the correct dielectric constant.
That's
Who knew?
Fluid gas.
Apparently it was 81.2.
Good to know.
Don't know what that means.
You know what? I have, and this is what happens with a lot of the problems you get in engineering. Like, I know what they're talking about. It's an electrical property because the instrument was a radar system, and radar is electromagnetic waves, right?
Totally.
So that probably means that electrical properties are important. I have no idea how you would derive that, nor do I have any idea the specific effect that that has on the radar wave as it bounces off of the water and comes back to the instrument. But I kind of know where I would find that information. NIST, the government agency, said it was 81.2. Some other random website said it was 83. So it's probably about 80 something. But having that background in electrical concepts, and then having the ability to look for information in reliable places, not just Wikipedia or random website, and the ability to, skim through a manual and say, oh, because all it said on the interface was material property DC. I was like, direct current? That doesn't make any sense. So skim the manual, find that property. Oh, dielectric constant. Well, what's the dielectric constant of water?
I don't know.
I don't know. Let's look on the internet, because I mean, even if, and this may have happened, like I may have learned this in college because I took electrical engineering classes. It's gone, but the basis is still there, and through experience, which internship is a great part of, you get sort of that ability to pick stuff up quickly, learn quickly, and just figure stuff out.
What units is it in?
I don't know.
I wanted to.
Just recently, I learned that the units for conductivity are modes. And conductivity is the opposite of resistivity of electricity. And that's, the unit for that is ohms, so it's literally like the opposite.
Siemens?
It's like backwards.
Microsiemens?
Lowe's and Siemens are the same.
I don't know about that.
I only know when it pertains to water.
We gotta figure it out.
I'm not an
That's the
engineer.
job. You gotta figure it out.
Doesn't have a little thing on it? Like, no, well, we got
Conductivity is a big deal in semiconductor because water is not actually conductive. It's the salt ions in the water that are conductive, and if you have a reverse osmosis system, which is attempting to remove said ions, you end up being able to measure how clean your water is by how well it conducts electricity. Also, you have to be careful of plastic pipes because they build up charge. Also didn't know that until I got into the field. They were like, don't touch that pipe. I'm like, you got it.
Don't ask me questions. Ask them
What,
questions.
what are your guys' work weeks like? Like, how many days do you work and, like, what hours? Like, I know you already said yours are kind of all over the place.
I mean, when it starts snowing, I know that it's time to warm the car up because there's a particular pump station that's going to croak. But generally 9 to 5, Monday to Friday. If there's not an emergency that requires attention, I'm not going to work past 5.
So, like working from home, like if I'm working actually from home, I will typically start my day at about 7 o'clock, so I can stop working at 3. If I'm going into ADI, I'll get there at 8 o'clock and I'll leave at 4. And when I meet Jesse, I meet him at 9, and then I drive home after working with him. Usually it's 4 to 6 hours, and I do the rest of that at home as well from there. So
I don't wake up early.
it depends on where you're going. At least for OCD, they're pretty flexible with where you take your hours. If you need time off for whatever reason, just let them know, hey, look, I'm gonna work an extra 4 hours this day, an extra 4 hours this day, so I don't have to work Friday. All right, good to know.
Yeah, you get paid time off. You get benefits.
Yeah, or you could take a PTO day. I'm allergic to taking PTO, so I tend to like just try to shove the hours elsewhere and then just have my free day instead. But he doesn't seem to care too much as long as you just let him know, hey, I'm not going to be available at this time, if that's okay, and as long as you get your 40 hours in a week.
Most places have an amount of work, what needs doing.
And even though we all work for the same company, it's kind of like Jesse has a cluster of clients because we've been with the company for so long. He kind of manages his own thing and then checks in with the boss. I'm starting to become that way with Analog Devices and Camus because I live in Vancouver. Our company is kind of based in like around Oregon City. So it's kind of like I might decide what I'm doing for the day and what I want to work on. It's not necessarily every day, hey boss, what do you want me to go do? And things can randomly pop up. Jesse might be like, I need you here, or another coworker, Stacy, might be like, hey, can you help me with XYZ? So it's totally, you need to be able to manage your time and make sure you are efficient with that time.
So I'm typically at my desk about 5:30 in the morning. We have a meeting at 6 with the superintendents to discuss what jobs are going out on the trucks today. So then I can figure out if any of my jobs are going to a line crew. So that if I do have a job that's going out, I can review it. Because typically, like, by the time, when I do the designs to the time that the stuff actually gets built is usually about a year and a half. So I have to go back and re-look at the stuff I did a year and a half ago and see, is there any potential problems that are gonna pop up? Has anything changed, that we need to tell the guys about? And if everything's smooth, then the trucks usually leave about 8 in the morning, and then I'm out in the field about 8:30, 9 o'clock, kind of looking at the new stuff I'm designing right now. And then I usually do that from like 9 to about noon, depending on the work volume. And then from noon to about 3 or 4, I'm at my house doing emails, phone calls, that kind of stuff. How many emails do you guys think I get a day?
Oh dear Lord.
About 60. So
That's the ones you care about, not the
right.
all the spam.
And we were going to talk about communication, because like when you get 60 to 70 emails a day, if it's longer than like 3 or 4 sentences or the grammar isn't right, not reading it. So.
And if it's important, they'll email you again.
They will, yes.
That's how you know.
They'll call you, right.
Yeah.
I'm an office jockey mostly. I probably half work at home, half work at the office. Just kind of get the work done. A lot of meetings. If I go out in the field, it's because something's gone really wrong that the more field staff people can't do. So, probably 40 to 50 hours a week and Monday through Friday stuff. If something goes wrong, then you can do a Saturday or a Sunday or something like that. So.
Yeah, I'm about the same. It's like 40 to 50 hours a week. And we have like flex hours, like so you can get in, like start work around like between 6 a.m. and 9 a.m. That's the window to start, and then 3 p.m. to 6 p.m. is when people leave. Currently, I work most of my days in the office. It's like 3 to 4 days a week in the office, and then 1 to 2 days like teleworking. When I was in facilities, it was like most of the time teleworking, and maybe 3 days every 2 weeks in the office. So it depends on like what group you're into. I think the general move, like for the industry, is to go more into the office because we have these buildings you have to keep at a certain temperature, and that's expensive. So you want to justify having those buildings and put people in them. I travel out in the field like maybe 1 to 2 times a month. Other people in my group go every other week or so, and they usually drive out to places like Montana or Idaho. Sometimes they take the plane. I think I really enjoy like going out in the field, even though when we're out in the field, it feels like we have like 3 days of work that we have to catch up on when we get back in the office. I feel like it's maybe more efficient because you're meeting face to face with people, and there's like less of a chance for miscommunication. That's the best form of communication, I think, is face to face. Even though like engineers tend to be introverts and they don't really want to like go into meetings. I just want to like be able to like text or call.
Hide.
Yeah,
Hide.
away. Yeah.
Read my mind, dude.
Yep. But you know, up front, it's kind of seems like a lot of work, but in the long run, you kind of solve a lot of issues like with face-to-face meetings.
Yeah, you guys are gonna have an interesting environment you're going into after the pandemic and everything. Everybody went all teleworking, and now they're like, we'd kind of like some people to be back in the office sometimes, and some jobs you can, some you can't. So it'll be interesting to see how that shakes out.
We have about 4 minutes left, so if you guys have questions, now is the time.
I have some videos on a thumb drive, but I don't know how to play them. Do you guys want to see videos? Or?
Yeah.
Okay. If you don't have any other questions, but
This might be a little personal. How much debt are you in, if you're in any?
Like mortgage or just college?
College.
I got about $66,000 still to pay off.
Saying about around 15, even though mine was only a 2-year, I lived off my loan because I decided not to work during school.
Okay.
I think that led me to focus on school to get a better job, but it's still, I ate ramen and boxed macaroni off of loan money with interest, so it's
See, I happen to actually not have any, but like I said, I went military before, so I had all those.
Paid for it in other ways.
I paid for it with 6 years of my soul instead. So is that, would you consider that debt?
If so, then I'm in debt to my mom, so.
I will say the career that I got out of the debt, I'm able to live comfortably. I have a house. I was able to buy a house like 6 or 7 months in, so I've got a house. I'm able to.
Do you have the remote? The remote's on his desk. Oh, it's right there. Or you're tall enough, you can probably just stand up and put it on.
I'm just a woodshop teacher. They didn't give me a projector.
I saw your sweet apron earlier. I mean, that's slick.
I'm making a bunch of boxes for one of the student government thing.
Yeah.
Oh, cute.
We had a bunch of cabinet wood donations, so just making them out of that.
He's having a blast.
I get absolutely filthy if I wear something.
Is working
So
the
I've
remote
got
harder.
some designs here if anybody wants to see them.
Yes, please.
Okay. While that thing's getting fired up.
Oh, there we go.
There you go.
So I put together a couple hundred of those a year.
Okay. You say a couple hundred?
Yeah.
The joys of
Couple is
keynotes.
2. Couple is 2 then.